He's something. And then I said, okay, I made you these cushions. Happy early birthday. He's like, oh, this should not be my birthday present. I'm like, what are you talking about? This took me like all day. I was frustrated. Anyway, brothers. All right, so chapter four is all about congruent triangles. Yes. Gosh. I only have one page left, so I better not write too much. Okay. So 4-1, we're going to start with just congruent figures. Okay, so in order for figures to be congruent, are the exact same size and shape. So it has to be both size and shape. So you can never have a triangle congruent to a rectangle, for example. This also doesn't mean that all triangles are congruent because they would literally have to be carbon copies of each other. So if one's the right triangle, the other one has to be, all their sides would have to match up, all their angles. So we can also say, so all corresponding parts must be congruent. Okay, I'm going to draw you a pentagon here. I'll try my best to make these the same. That's pretty good. So I'm going to label these A, B, C, D. And I'm going to mark that these two are. All right, so if I know for a fact that I have two figures that are congruent to each other, so let's say it's given to me, hey, yes, these two things really are congruent, that gives me so much information. All right, so first of all, what we like to write, once we establish that two figures really are congruent to each other, we write what is called a congruent statement. And basically all that is saying, hey, figure A is congruent to figure B, but when we name them, you can name the first one any way you want, but here's the trick. So for the first one, I'll just name it A, B, C, D, E. When I go to name the second figure, what we have to do is we have to match up the pieces. So whichever angle corresponds with angle A, and I know it gets confusing because we just use corresponding angles with parallel lines. We just mean, when we're saying corresponding now, we're just meaning the ones that match in the other shape. So who would match up with A in my second shape? Sam. R, right? Everybody see that? So R has to come first now. You can name that first one any way you want, but when you go to name the second one, you got to match up the pieces. So I'd have to go R, and then what? Matches with B. Q, And then I would just work my way around, right? So then next would be P, T, S. The order matters a lot. So we'll put a big star. Must name second figure to match the first. But here's what's so cool about this, ladies and gentlemen. If you have a congruent statement, this gives you so much information without even looking at the diagram. Watch, I'll even cover up the diagram. Look, it's gone. Just by looking at this, you can tell me what angle matches with angle D, let's say. What angle would have to be congruent to angle D? Angle T, because they're listed in the same spot, right? D is second to last, T is second to last. Oh my gosh. So if this were a proof, you would get all 5 of these angles are equal to each other. A is equal to R, B is equal to Q, C to P, D to T, and E to S. And the other way, right? If I said who matches up with S, you could say E. Who matches with P, you can say C. Oh my goodness. So you get every single one of those angles. So let's say all angles are congruent, but that's not all. What if I asked you about the sides? For example, still, I'm not even looking at the image. What side has to match up with BC, let's say? QP, right? If I say side BC, that's got to match up with side QP because they're listed in the same spot. You mean to tell me that I get not only the angles, but the sides too? Yes, that's exactly what I'm telling you. My goodness. Is it Black Friday? Because I feel like I'm getting all the deals. You are. All angles are congruent and all sides. That is, oh my gosh. So if you are given a statement where they tell you the figures are congruent, you have all this information. Wow, what a big help. I know. I'm going to give you a little challenge and see if you can do this. Now, I want to remind you, in a single diagram, I can't reuse the same letters. So if I'm labeling a diagram and if I label one angle A, I can't then name another angle A, right? So I want you to try this. If I told you BATH, so some quadrilateral with vertices BATH, if I told you that is congruent to SETH, SETH, can you draw me a picture that shows this? So draw me a figure BATH that is congruent to figure SETH. Noticing that you have like the T appears in both. So you can't have 2 separate T's. They'd have to be the same T. Oh, try it. Also make sure that your match, so however you draw angle B, right? That's got to match up with angle S. So they should look the same. And remember that you can only have one T in this diagram and one H, even though they both have it in their names. To do it. Okay, has anybody come up with a diagram that they think works? You do. Would you mind if I put it on the screen and showed everybody?
No.
All right, let's see. Thank you. Oh, I think it's lovely. Let me zoom in. So basically, the only way to make this work is to make, your diagram might not look exactly the same, but they have to be sharing this side with each other, TH. So make sure that in your diagram, these two figures are sharing TH. That's the only way to make this work. And then make sure on one side you have BATH, and then you're basically got to flip it over SETH. One thing I should point out, which I'm not sure if I actually have or not, when you're naming any kind of a figure, it doesn't matter where you start, but you have to go clockwise or counterclockwise. So I couldn't do like BTAH. You can't jump across. You have to pick somewhere to start and then go around the edge either way, but you can't zigzag. So this would be perfect. Thank you so much. I'll show you what mine looks like. I usually do this. So I've got something like that. And then I do the same thing. So what do I have? B here, BATH, and then SETH. Okay, so the sides, I also like to mark the sides that match up. So these two sides would match, these two sides would match, these two would match. And then I hope you're starting to see how both of these shapes share TH. So when let's say I was trying to do a proof where I was trying to prove that these two shapes were the same, I could say, for example, hey, since they share side TH with each other, that has to be equal to itself. So that's a great example of when we use the reflexive property. We say things like TH is equal to itself, and that gets me that fourth side being congruent to each other. So I'll put 4 slashes on that one just to show that they're all the same. You could also mark all the angles, right? You would know angle A has to match up with angle S, A with E, T with T. Well, really, you couldn't do that. You would say ATH the same as ETH, and so on. Okay, any questions? No, we feel okay? All right. Okay, so I actually think I'm going to stop here. Or, I mean, we're not. Or do you want less tomorrow? And do, I have a little bit more to go, but I could stop here and do it tomorrow. Or would you rather get it over with now? Get it over with? Okay. All right. So let me mark this here. Are you being outvoted? It's not bad. I don't have much. I'll stop no matter what in 10 minutes. How's that? So even if I don't finish the next chunk. Is that all right? And then you have that much less tomorrow. Oh, pages. Hold on. Let me see if that pages over here. I do, yay. All right, so now what I want to focus on is just triangles. If I want to prove to you that 2 triangles are the same, maybe we'll just do this. Yeah, well, I'll just do one of the 3 that I was going to do. So I'll just do one. So it'll only take me like 5 minutes then. Okay, so this is technically 4-2, but I'll only do the very beginning. Proving triangles congruent. want to show that two figures are the same, one thing you can do, well, usually what you have to do is you have to measure all the angles and make sure that they match all the angles. And you have to measure all the sides and make sure all the sides match up in the other one. That's a lot of, so if I'm talking two triangles, that is now 6 bits of information that you would have to verify. That's a lot. 3 angles and 3 sides every time. My goodness. Isn't there a shortcut? Yes, there are 5. I'm so glad that you asked. So between today and tomorrow, we're going to talk about all 5. Today, I'll just talk about the first. Okay, if I, and I'm actually going to do this, let's say I took 3 different colors, a blue, an orange, and will a yellow reach? Yeah, okay. And a blue, an orange, and a yellow. All right, check this out. I'm volunteering you and you. What I need you to do is make a triangle end to end. So use all 3 and you got to connect them end to end. Okay. By the way, these explorers, I don't know if I'm sure I told you this, but the colors are the same length. So like the 2 orange sticks are always the same length. The 2 yellows are always the same length, right? Okay. I didn't give them any other directions other than take these 3 things. You had 3 that were the same. They each had 3 sticks that were the same length. And they created a triangle. I didn't say anything. They could have made it any angle they wanted. They could have done anything they wanted, just connect it end to end. Look what they created. The exact same triangle. Isn't that interesting? Will that happen every time? Yeah. Yes. There's no other way. If I give you 3 and 3, they're exactly the same. Everyone's going to make the same triangle. Sure, someone might have it flipped the other way. Doesn't matter. There's still congruent triangles. If there is a way that I could pick the 2 triangles up, even if I have to flip it over, rotate it, doesn't matter. If I can line it up so that those 2 triangles are exactly the same, they are congruent. So even if they drew it differently, upside down, whatever, they're still the same. That's so interesting. So that first shortcut is called side, side, side. I didn't even measure the angles. I didn't measure anything. They just automatically match. Wow, thanks, geometry. So to prove 2 triangles congruent, you can use one of 5 shortcuts. So we just talked about the first one, which is called side, side, side. Bless you.
Right.
Or, because again, we're lazy, we don't want to write all that. You can literally just write SSS. And it simply tells us if all 3 sides in one triangle are congruent to all 3 sides in the second, then the triangles are congruent. Without ever even having to measure the angles. That's so cool. I don't know if you get how cool that is, but it is. Now, what's interesting is that if I were to add a 4th side, so it wouldn't be a triangle anymore, obviously, it'd be a quadrilateral. So if I added this short little pink side in between the orange and the yellow, check this out. This is just gonna blow your mind. Are these 2 things guaranteed to be congruent? No, look. Ah! Oh my gosh. The same 4 pieces, but they're definitely not congruent anymore. Weird. Why does it work with triangles and not a four-sided figure, for example, right? I could make this, look, I could make this concave if I wanted. But it's still the same pieces. Yes, basically, they're what we call a rigid shape. So if you push on any of the vertices, like they don't cave in on themselves like this did. If I push on a vertex, I can move it. This is not rigid. That's why you see triangles in building structures all the time. Because it doesn't matter where you push on them, they're much more sturdy than this thing, right? This thing. Imagine if we made our bridges like this. Oh, that would be a disaster. Okay, so anywho, that's kind of why this works. So tomorrow we will pick up on the remaining 4 shortcuts, which are fascinating, but this is my favorite probably. Side, side, side. Okay, let me give you your homework. Not the right page. Okay, we are going to do, I'll only give you homework from 4-1 for now. And oh, I don't want to use that yet. All right, let's just do this. On page 119. Oh, sure, I am. Thank you. Let's do numbers. Let's just do 1 to 16. We'll make it easy. You might be able to finish before you go too. They're pretty short. Okay, that's it. Let me go open that up on Jupyter.